Hey there, geometry students. Alright, you're back with Mr. Klinkerman. We are starting section 2.7, in which we're going to revisit some things that we've learned before in chapter 1, but we're going to approach them a little bit differently. We're going to approach them from the perspective of proof. What we're going to be looking at here are angle pair relationships. And some of those angle pair relationships that we've visited before that we're going to visit again now. Vertical angles, supplementary and complementary angles, linear pairs, all those things are going to be talked about in this section. But there are going to be proofs and theorems involved with each of those types of angle pairs. And so in this section there are two learning goals. You're going to prove statements about angle pair relationships, and you're going to use angle pair relationships to find missing angle measures. And actually the second of those goals we've done before. Reinforcement never hurts though. And so let's get to it. And I want to start with a proof, all right? And you see in this proof, I'm telling you that angle 1 is complementary to angle 2, and that angle 3 is also complementary to angle 2. And what I'm wanting us to do is to be able to figure out why in the world does that mean that angle 1 is congruent to angle 3. Now what I need you doing right now is pausing the video and copying down all the information that you see, the picture, and all those things that you know are required when you're writing down a proof. Go ahead and do that, and if you know how to do the proof, by all means, try it out on your own. But I'm not necessarily expecting that you know that quite yet, so you can just unpause after you've done everything and watch me do it. Alright, the first thing that you're going to see me do here is mark off a little bit of information that kind of illustrates what we're given. When it says that we have complementary angles in a given statement, that means that we have angles that add up to 90 degrees. And since angle 1 and angle 2 are complementary and they're adjacent to one another, as well as angle 3 and angle 2, that means that we've got a pair of right angles in the picture. And so I'm going to go ahead and mark that. We know that this angle is a right angle, and we also know that this angle is a right angle. Okay. So let's talk about our strategy here. I'm going to mark something down on the picture as a hypothetical. Let's hypothesize that angle 2 here is a 40-degree angle. Okay, and what I'm wanting us to see is what does that tell us about angles 1 and angle 3, because we're trying to prove that those have to be congruent. So it shouldn't really matter what angle 2 is here. Just angle 1 and angle 3 should be congruent because they're both complementary to angle 2. Alright, well, since angle 1 is complementary to angle 2, that means angle 1 would have to be 50 degrees, right? And since angle 3 is complementary to angle 2, that means it also has to be 50 degrees. And if angle 1 and angle 3 were both 50 degrees, they'd be congruent. Now again, I made up those angle measures. Those aren't actually part of the proof, but I wanted you to see the thought process that goes into proving that those two angles are congruent to one another if they're both complementary to angle 2. Alright, now for the proof. Alright, then since the measure angle 1 plus the measure angle 2 is the same thing as the measure angle 3 plus the measure angle 2, they both equal 90, that means you can set them equal to one another by the transitive property of equality, or substitution property of equality if you prefer. Alright, now look at the next step in the proof. Notice that in that last equation I made that I've got the measure angle 2 on both sides of the equation. Alright, I got that there, and I got that there. And then, you know, what's going to happen if I go ahead and subtract that from both sides of the equation? Well, it's going to cancel out, and it will give me this equation here that the measure of angle 1 equals the measure of angle 3. And we said we subtracted the measure angle 2 from both sides. So that's the subtraction property of equality. And then if the measure of angle 1 equals the measure of angle 3, then of course angle 1 is congruent to angle 3. And that's by the definition of congruent angles. Alright, what I've just demonstrated to you is a proof of one of the new theorems that we're going to be learning in this particular section. And that theorem, I'll go ahead and write its name down, is the congruent complements theorem. All right, and basically the congruent complements theorem says that if two angles, like 1 and 3, are both complementary to the same angle or congruent angles, they got to be congruent to each other. And really, I went through the proof of the theorem to show you that we are dealing with theorems, and every theorem can be proven in some way. All right, and now we don't have to prove it. We just know that if angle 1 and angle 3 are complementary to the same angle, that by the congruent complements theorem, they'd be congruent to one another. All right, and we'll use that fact many times throughout the year. Now, I said there are some new theorems that we're learning in this chapter, in this section, obviously in this chapter, but in this section in particular. And these next several slides are going to go through the 4 theorems that are in this section that you need to know. And when I say you need to know it, you should be making flashcards of these things or something along those lines, just like you would with vocabulary. Because if you don't understand these theorems, there is absolutely no way that you're going to know when to apply them at the right time. And you will need to apply each of these at various times throughout the year. Okay, so some new theorems, and the first one we're going to deal with is the right angles congruence theorem. And what I'm wanting you to do is this. I'm wanting you to explain how the indicated theorem justifies that angle 1 is congruent to angle 2. And we're going to have several slides where I have an angle 1 and angle 2 that will be congruent to one another, justified by a different theorem each time. And you need to look in your textbook, hopefully if you have it with you, or look it up online for goodness sakes. See what the theorem is that I write down, and see if you can determine why it means that the two angles in the picture would have to be congruent to one another. All right. Now, one little added piece of information for this one that will help with that is that these two angles are right angles. Okay, so why would angle 1 have to be congruent to angle 2? Well, if you've looked at a right angles congruence theorem, you know that the right angles congruence theorem says that right angles are always congruent to one another. And this seems self-explanatory, but it is a provable statement. If angle 1 is a right angle, isn't it 90 degrees? And the same with angle 2. And if they're both the same measure, then they have to be equal to one another. So the right angles congruence theorem would justify that angle 1 is congruent to angle 2 this way. Since angle 1 and angle 2 are each right angles, their measures are each 90 degrees, and thus, that's an ugly H right there. All right, thus angle 1 is congruent to angle 2. Hopefully that makes some sense. Pretty self-explanatory, I'm hoping. All right, let's go on to another one. Here's another picture where angle 1 and angle 2 are congruent to one another. And I want you to use a theorem, in this case a congruent supplements theorem, to determine why they're congruent to one another. Again, hopefully you've got your textbook in front of you, and I'd like you to read that theorem and then try to justify this statement. All right, or look it up online. I'll give you a moment. All right, and here's basically the thought process. If angle 1 is supplementary as it needs to be because it's a linear pair with that 48 degree angle, then that means angle 1 has to be 132 degrees. All right, and angle 2 forms a linear pair with a 48 degree angle as well, so it's also 132 degrees. Well, since angle 1 and angle 2 were both supplementary to 48 degree angles, that ultimately made them congruent to one another. All right, so that's what we're going to say here. Angle 1 and angle 2 are supplementary to congruent angles, all right, the 48 degree angles, so angle 1 is congruent to angle 2. Real easy, right? Okay, so congruent supplements theorem. Now, here's the congruent complements theorem, of which we just made a proof for a moment ago. And for this one, you need to know that this is a right angle and this is a right angle. Alright, and so how would the congruent complements theorem make angle 1 congruent to angle 2? We'll just think this through. If angle 1 is complementary to that 21 degree angle, as it needs to be since they're adjacent angles that form a 90 degree angle, that means that it's going to be 69 degrees. And from the same logic, angle 2 would be 69 degrees. So since angle 1 and angle 2 are each complementary to the same angle, they're congruent to one another. Alright, and that's exactly what I'm going to write. Since angle 1 and angle 2 are complementary to congruent angles, angle 1 is congruent to angle 2. Alright, now there's one more theorem that we're going to talk about in this section, and it happens to be a fact that we've used many times over, and there's a postulate that we still need to discuss as well. And the postulate and theorem that we need to discuss are these. We need to discuss the linear pair postulate, and then we're going to try to prove the vertical angles theorem. Those are the things that we've used before, but we've not called them postulates and theorems. Alright, and so what I want us to do is to use the linear pair postulate and the congruent supplements theorem in order to prove the vertical angles theorem. Now, what is the vertical angles theorem? Well, again, hopefully you got your textbook to look this and this up. All right, these are the new things for this slide. And if you've read those two things, you know that the vertical angles theorem says that if two angles are vertical angles, they have to be congruent. And so that's what we're trying to prove here, is that if angle 1 and angle 2 are vertical angles, as they are, then angle 1 has to be congruent to angle 2. You already know this is true, but let's see why it has to be true. How can you prove that it's true? Alright, well, in our reasoning here, I think you can see that angle 1 and angle 3 form a linear pair, and angle 2 and angle 3 form a linear pair. Now, that should mean that angle 1 is supplementary to angle 3, right? As angle 2 is supplementary to angle 3. And since they're both supplementary to angle 3, that means that angle 1 has to be congruent to angle 2. Pause the video and see if you can use that logic to write this proof on your own. Alright, turns out that this is a three-step proof when we start using the postulates and theorems that we already know. Now, in this picture, we already said that angle 1 and angle 2 are vertical angles. That's given, of course. How do you know that the measure of angle 1 plus the measure of angle 3 is 180, and that the measure of angle 2 plus the measure of angle 3 equals 180 degrees? Well, that's based on the linear pair postulate. We know these are a linear pair, and that linear pairs are supplementary to one another. We know angle 2 and angle 3 are a linear pair, and linear pairs are supplementary. And in fact, for your reason, for statement 2, you can write one of two things. Ordinarily, I would just write linear pairs are supplementary, but it's the linear pair postulate that states that fact. So you can write the name of that postulate instead of just saying linear pairs are supplementary. Either is acceptable. Alright, and then if angle 1 and angle 3 are both supplementary, if angle 1 and angle 2 are both supplementary to angle 3, then they've got to be congruent to one another because of the congruent supplements theorem, right? Alright, that proves that vertical angles are always congruent to one another. It's not something you have to have a doubt about. Alright, hopefully this has made some sense. We're going to work on those angle pair relationships in class tomorrow. Thanks for watching. Peace.